Saturday morning.
They might be
Very
more
nice.
funny now.
All right. So the next update is from the Onyx GenAI working group. Yamini and Javier are not able to join us. So yeah, Yamini is on a sabbatical this month. So anyway, the GenAI working group has been active for the last 1 year. And actually, a lot of the technical discussions relating to Onyx over the last year have happened in this working group in the context of the Onyx GenAI working group. So it was originally formed basically with the goal of enabling us to represent recent GenAI models in Onyx to address limitations we saw at the beginning or middle of last year. But the technical focus of the work itself overlaps other SIGs like the operator SIG, converter SIG, and other new areas. So I'm going to just give a quick short summary of what was done. So there were a bunch of new operators added to address the limitations seen. You see some of the examples here. So the tensor scatter, for example, well, it was accompanied by updates to the attention operator. And it's not mentioned here, but the attention was a pre-existing op, but it was updated. And the goal was essentially to support in-place updates to KV cache, which is pretty critical for having good performance. And so this is a standard-based approach to representing that. And linear attention is another new op. That was motivated by recent models like Mamba, Quen 3.5, Nemotron, and so on. Again, this is a new operator that tries to reduce the overheads of attention. As the name implies, it avoids a kind of a quadratic blow-up that shows up with standard attention. And so that was added to the standard as well. Now, flex attention, I'll say a bit more later, I think. And it was introduced into the experimental domain as a generic higher order op in order to express variations of the attention op. So I'll say some more about that later, I think. Now, there are other topics, some topics that have been discussed. So a couple of operators that were briefly discussed was paged attention, which is sort of implementation technique, but you do need to explicitly represent it in Onyx slightly differently. It becomes important when you run into, for example, KV caches that are too large to fit in the available memory. And then you start using paging-like techniques. So, and then there is mixture of experts, which Onyx runtime does have a way of representing it using a contrib op. There's been some discussions on what to do in the Onyx standard itself, and there is a proposal, an issue to introduce a group matml op as a generic way to represent the core of MOE. And these two are on the operator side. Apart from this, there's also been another topic that has been discussed as quantization formats, especially the ternary valued tensors where the values are only 0, -1, and +1. And because there are only 3 values, using 2 bits is a bit wasteful. So this is an optimized storage format. It's more for secondary storage or representing in the model itself. But obviously then there's the question of how do you load it. And this, there have been some proposals, and this is some ongoing work. So, apart from introducing operators, obviously there is this question of how do you get models using these operators. So you heard a lot about this already, but So I won't spend time on this, but mm, again, before the new approach, you have heard about using agents or authoring models directly. Of course, exporter was the most viable, most useful route to generating models. And um, in that context, uh, we worked on ways to ensure when you use the PyTorch to Onyx exporter, you are able to generate models that make use of these new operators. And that often involved introducing fusion optimizations. For example, because typically from a transformer, when you do a name export, you might end up with a flattened graph with several dozen nodes representing primitives, which actually correspond to a single high-level operator like attention, and you need to recognize this subgraph and replace it by a single few stops. So in addition to introducing these new operators, there was work on the converter side, on the exporter, and the fusion, so on, to make sure you can generate models that contain these operators. And and we also work to some extent with Hugging Face exporters and Optimum Onyx, which are a layer on top of the PyTorch exporter. And again, some of those were using the older exporter, and there was a need to migrate it and to use the latest exporter and so on. So there was work on the exporter side. And of course, and you have heard about the work on Mobius from Justin, and Xavier referred to it also. So in addition to using the exporter, you can now directly author the models, and there are useful frameworks and infrastructure to do that conveniently using agents. So you can generate these models that way. All right. So other than this, there are a couple of other topics that came up in the context of this GenAI working group. So one was focused on enabling backend specific optimizations. So this goes back to this, well, this question that has troubled us a lot, which is in Onyx, we want a single model that will work on different backends. That's been kind of an ideal goal, viewing Onyx as a spec, but really often you end up using Onyx to deploy it on different backends, and often you need to do different things to make sure you get high performance. So there's always been an interest in generating specialized models that are optimized for particular backends. So that was, so there are a couple of two or three problems that show up in this context. So there are, so I just list some of this here, but I won't get into depth. So there was this question about, well, do you try to capture all the model variants within a single model? So there was some discussions and proposals on how to do this, but right now the thought is that's probably too complex and maybe not worthwhile. So the move right now, the plan is to more focus on something what's shown here as the second item, which is packager pattern, which is, the idea is, well, just generate different Onyx models for different backends. They'll just be different Onyx models, but use some higher level packaging mechanism that tells us that these are all variations of the exact same model. So, but based on your backend, you can choose the right one. But so there is extra metadata that tells us these are just variations of this standard model, but you enable backend optimized models this way. So I'll skip some of this. I mean, there are these questions about, one of the technical questions is weights. If you have multiple variants, if they decide to quantize for different formats, you end up requiring different weights. And if you want to download all of them, that can be a significant overhead because you're talking about large models here. But that's a technical challenge. I don't think there's any simple solution to that. But if you're going to download only one variant, then it's not a concern. So other than this, the other aspect that comes up is also enabling ahead of time compilation by this. So in the earlier slide, we were talking about actually different ONNX models. They are still ONNX standard models, but sometimes people want to go all the way down to compile it down to maybe binary format or other variations, and doing it ahead of time saves you. Well, it's more efficient than doing it just in time in several settings. So how do you enable that? And ONNX runtime has this notion of a EP context operator, which is essentially a operator that allows you to bundle binary data within it. And that seems to be the plan is you would support ahead of time compilation using an approach like that. So apart from this, one of the other topics that came up was standardizing GenAI API at the C++ level. This is this is not something I participated in much, so I can't say much more about it. But it's sort of an interesting topic to keep in mind is that it is slightly outside the scope of ONNX itself. ONNX has focused more on the ONNX as the representation, and whereas this is moving to a standardizing C++ interfaces for specific GenAI context. Anyway, so all right, and GenAI working group will continue to meet monthly, and please feel free to join this. So some of the topics I mentioned continue to be of interest, and they're still being discussed. So anyway, I'll stop here and answer questions if any.
That's great.
Okay.